Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to show you a little bit more about how to work with surface moorings. What we're going to do today is use the data well template mooring. It's in 200 meters of water. I'm going to show how to start with a static mooring profile. Start your dynamic analysis in waves with a static mooring profile. So this is ProteusDS Oceanographic Designer. You can see in the environment settings, there's the mooring detail. In the environment settings, we have a relatively mild current, a linear shear to the full ocean depth. However, if you jump straight to a dynamic export and then look at what the current profile looks like, save it in this folder here, dynamic start. When you open it in ProteusDS Simulation Toolbox to look at what happens in wind, waves, and current, the starting profile is just a simple diagonal line. It's not like, that's not representative of what the current, the mooring will look like in the current profile you've specified. So how do we do that? It's a good idea to do this because it's a more realistic starting position to begin your dynamics. If you just want to let it drift to position in the dynamic simulation, it's going to take a little while because the currents are very weak and it takes a long time for the mooring to respond and get to the same shape. So to do this, we start with a static analysis. So we go back to ProteusDS Oceanographic Designer, click Analyze, and this time we're going to do static. And it's going to automatically generate the static files for us. Call this folder static. And the ProteusDS Simulation Toolbox folder for static. Now, the difference is here in ProteusDS Simulation Toolbox, we're working with a quasi-static cable model. And this responds to find a static solution for a mooring line. So we do start with a static line, but it's going to relatively quickly resolve the static profile of the mooring that we want to work with. So let's run that. Once this has completed execution, what we want to use is the export capability from ProteusDS Simulation Toolbox. The export capability takes the final state from the output of the simulation so that we can use it as a starting point for the next simulation. So you can see from the progress bar, the simulation is now complete. Let's just take a peek at what it looks like. It's not a bad idea to make sure it's converged properly. So open post PDS. This is the post-processing view. Like engineering view here. I'm going to pick the east. In this perspective, this is with the current flowing from the left to the right when the current's going to the northerly direction. So there's our starting profile. And the way that quasi-static cable works is it finds the zero current profile first. So this is there's some flotation here, and then there's some hardware providing some sinkage to the buoy, and then this is what the profile looks like in that linear shear current profile. So this is what the mooring profile we want to use as a starting point for our dynamic simulation. So I just wanted to look at it and make sure that it completed properly. So we go to export final state, and we're going to change the name here, and we're going to go dynamic. I'm going to call this wave seed 1. We're going to come back to this project in a second. Select folder, project name dynamic. Okay, now it's going to ask us to open this new project in a new window of ProteusDS Simulation Toolbox. So we want to do that. We don't need this static one anymore. We can close that. So a couple things we have to do here. The first thing is we have to manually change the model from quasi-static cable to a cable so that we can solve the dynamics through time, and we need to do that for wave modeling. Behind the scenes, this is something that ProteusDS Oceanographic Designer does for us when we switch to exporting dynamic. In ProteusDS Simulation Toolbox, make sure you've highlighted quasi-static cable. Go to convert the object under the configuration menu. This is the only object you can do, so it's pretty straightforward. Quasi-static cable to cable, pick the mooring, go OK. Now, under environment, you'll see that we already have our current profile set, which is great. We want to change, we want to add some waves here and see what's going to happen to the system in waves. So we're going to set wave type John swap. That's a pretty common irregular sea state to use. You can right click here, pick available values for property and 8, but you can just type in 8 if that works for you. My favorite property in ProteusDS Simulation Toolbox, resolve faulted property. It's going to tell you everything else you need to provide as inputs for this John swap sea state. So wave height, this is going to be the significant wave height because it's an irregular sea state. I'm just going to pick 5 to work with. Wave period of 9, that's pretty reasonable for sort of a strongly wind-driven swell, so just to leave that as a default. Number of wave segments, this is another topic entirely, but we need to have enough to get an accurate representation of the irregular sea state. And I'm going to set that to 75. More on that later. And the seed here is sort of the seed for the random number generator that's generating this specific time domain wave state from the John swap spectrum. We'll get more on that in another tutorial as well. In the meantime, the last thing we want to do is set our simulation time. We'll set it to say 300 seconds. We need a bit higher resolution than 1 second output rate in our file output, so we're just going to go 0.1 and we're good to go. Now we've got our first wave state simulation running. And it's going to start with, if we look at the visualizer, you can see we don't have that diagonal line anymore. It's got that nice profile to start our wave dynamics. So I just wanted to show you in this video how to go about starting a dynamic simulation with a static profile of a mooring when doing mooring design with ProteusDS Oceanographic. Thanks for watching.